What it do, family? It's your boy Codehova with Fly Combinator. We're pimping Swift, and we're gonna talk about the sticky hairy issue: reference type versus value types, aka classes versus structs. Okay, so here I have a class. It's a class of a hustler. All right, and the hustler only has a name, and because it's a class, we have to give it an initializer. So let's just create a variable, Codehova1, all right? And then it's going to be of a type hustler, and let's give it the name Codehova, okay? So basically, when we create this variable of Codehova1, when we instantiate this type, instantiate a single instance of hustler, it's going to be placed into Codehova. But what the difference of classes, right, is that in here it's going to be of an address in the computer's memory, saying it's going to be like some crazy shit, right? It's going to be like number 450 blah, blah. It's going to be some real wild shit. Really, in my honest opinion, you don't really need to know that deep into it. I mean, once you get down into coding, learning how to write these languages and build applications, then you could like learn more about it. But right now it's not really important. Just know that this instance, it's placed in an address. So it's like in the memory, it's at 408 Main Street. All right. So this instance is placed in some other address. All right. So if we create a new variable, Codehova2, and we make it equal to Codehova1, this is also this value. It's just holding an address. And that address, it's going to be the same. 401 Main Street. Or 408. Okay? So, if we type out Codehova1. My bad. Codehova1. It must be because of green tea, man. Because my brain is jumping right now. But we get out the name. Codehova2. We get out the name. And let's run this. So we see that the name on both of these variables is Codehova. All right. But like I said, to the computer, because this is a reference type, the reference is at this object. The reference is a place in memory. So it's in the computer sense, it's on 408 Main Street. If you want to find the value of Codehova1, it's on 408 Main Street. And because we made Codehova1 equal to Codehova2, it's just going to hold that same address of 408 Main Street. So if we updated Codehova2, or just 1 for right now, and we made the name equal to Hove, all right, Hova. So we updated the value of the name, but because it's still held on 408 Main Street, all right, it's still held there. So if we were to print this out, what do you think is going to happen? Because these name values, they're at the same address. They're still at 408 Main Street. So if we run it, boom, both of them spit out the new value. And that's because the value is stuck in a place in the same memory. All right? Seriously, when I saw this the first time, I really didn't understand what's going on. But just again, when you create this instance of hustler and you make it equal to Codehova, right? This variable, all it's gonna be holding is an address in memory of where the values live. And because we made Codehova1 equal to Codehova2, both Codehova1 and Codehova2, they're all pointing to the same address. So what's going to happen? When you go to that address, it's going to be one object. And that one object that's there, you could change that object. You could delete the object. But at the end of the day, these two variables are going to be pointing at the same thing. So because we changed Codehova to Hove, whenever you call the name on any of those objects pointing to the same address, it's going to be the same value. All right. So let me show you the difference of reference types versus value types. So let's create a struct. All right, let's create a struct and let's call it a Mac. And this one also just has a name. And because it's a struct, we don't have to write any initializers. We get it for free from Swift. All right, so let's say this one is going to be Pimpin' Ken. And this is going to be a Mac. And we're going to give it a name, Pimpin' Ken. Okay. So Pimpin' Ken, let's also create a new variable. Let me change Pimpin' Ken to a variable. And let's call this one Joe Blow equals Pimpin' Ken. So right now we're dealing with two value types. So let's just call both of them out. Pimpin' Ken.name, Joe Blow.name. And if we run this, we see that they both spit out Pimpin' Ken. They're value types. So what did we do here? We just changed one of their names, and both of them changed because they're pointing at the same address. Will it be the same? Will it be the same for if I change Pimpin' Ken, his name, to Ken? Okay. So what will be this case? Be a var. Oh, my bad. So that should be a variable instead of a constant. So we could change it. We see that it goes from Mac. When it's a struct, only that single instance gets updated. Both of them don't get changed. Let me create a better example because I think the differences of the names makes it a little fuzzy. All right. So let's just call this one Joe Blow. So we got var Joe Blow 1 equals Mac. All right, this one's gonna be Joe Blow. And then we got variable 2 of Joe Blow 2 equals Joe Blow 1. So Joe Blow 1 dot name, Joe Blow 2 dot name. So let's run this. All right, both of them are Joe Blow. So we made Joe Blow 1 or Joe Blow 2 equal to the value of Joe Blow 1. So let's see. So in the previous example with classes, we just edited Joe Blow 1's name to the realist out. All right. So again, let's print out these values. Nope. When we're dealing with structs, they're values. So over here with classes, they're held on when you create a class type, class instance, the value that you create for it, it's going to be stored in an address. So if I make Codehova 1 equal to Codehova 2, they're both just holding a reference to the same address, all right? But when we deal with structs, which are value types, when I make Joe Blow 1 equal into Joe Blow 2, Joe Blow 1 is going to give the value to Joe Blow 2. They're not pointing at the same address. They're the same. It's like Joe Blow 1 is given the information to Joe Blow 2, and they're both going to be running in their own way. They're going to be their values are held in different addresses. So if you change one, since I changed Joe Blow 1's name, Joe Blow 2, it's doing its own thing. It's independent. So that's the difference of classes and structs, aka reference types versus value types. So when would you use this, right? So you use value types when you're dealing with data that you don't want to be messed with from other parts of the code. All right. And classes, you might need to just make sure that one value exists just one time in your memory. All right. So if you're gonna mess with it here, you're gonna mess with it there. You just all want them to always be updated. So that's when you use classes. When you use structs, data types, it's when you want to make sure that your data is untampered by other places in the code. So that might be a little over your head, but anyways, that's the subtle difference of classes and structs, reference types versus data types. This one if you have any questions, definitely place it in the comments below. You know, we're going to definitely dig into it, maybe with more videos. But it's your boy, Codehova. We pimpin' Swift, fly Combinator all day. Let's get it.